Hello children, today we are going to learn about what happens when we place a dipole in a uniform electric field. We all know what is a dipole, right? A dipole is two equal and opposite charges separated by a small distance. The distance between the two charges is taken as 2a, right? Okay, and also we all know to draw a uniform electric field. We know that the space between the lines in a uniform electric field will be equal. Okay, so roughly I'll draw the diagram now. Okay. So while you are drawing, you have to match it this way such that the space between the lines are uniform. Okay. So now I am going to place a dipole here. Okay. So this dipole is having two charges. One charge say plus q here, another charge say minus q here. And the distance between the two charges is taken as 2a. And please note that this dipole is placed at a particular angle with regard to this electric field. So this angle is taken as theta. Okay. So any object you would have studied in your grade 11, any object will be subjected to two types of motion. One is translational motion and the other one is rotational motion. Similarly, when this dipole is placed in the uniform electric field, this will also experience force, which will be the reason for translational motion. And what will be responsible for rotational motion? Can you try to recall? The rotational analog of force is torque. Okay. So now let's see what is happening here. So now when this dipole is placed here, there will be force experienced at the two ends. Okay. So this force will be plus QE, which is taken as F1, and this force will be, F2, which is minus QE. Okay. So now what will be the net force here? The net force will be 0 because F1 and F2, that is the force exerted by plus Q charge and the force exerted by minus Q charge are equal and opposite, so that they cancel each other and the net force will be 0. So when the net force is 0, there will be no translational motion in the dipole. But these two forces are separated by a distance 2a, right? So two equal and opposite forces will separated by a distance will constitute a couple. This couple will in turn generate a torque. A torque will be experienced, right? So what is the formula to calculate torque? So we know that two equal and opposite forces will constitute a separated by a distance, right? Separated by a distance means it will constitute a couple. So now this will execute a torque. Okay. So how to calculate the torque experienced? Okay. So this is, so there are two equal and opposite forces. A couple is formed which will exert a torque. Okay. So now what is the formula to calculate torque? Torque is product of either of the force into perpendicular distance between the two forces. Okay. So either of the force means it will be QE. Now how to calculate the perpendicular distance? Let us redraw the diagram here. Okay. So now there is a dipole. Distance between the two charges. This is plus Q. This is minus Q. Okay. Force F2. This is force F1. as we saw earlier, F1, right? Okay. So now there is an angle here. Okay. So this angle is, with regard to this electric field, is theta, right? So now you need to calculate this perpendicular distance. This perpendicular distance. Yes. So how will you calculate this perpendicular distance? You know that sine theta is equal to perpendicular by hypotenuse. So what is the perpendicular here? We don't know the value. Perpendicular divided by, but what is hypotenuse? 2a, right? Okay. So now this is 2a, right? So now by 2a. So this will give us the value of perpendicular as 2a sine theta is equal to perpendicular. Okay. So the perpendicular distance is 2a sine theta. So now the forces, magnitude of the force is QE into 2a sine theta. This is the torque. And now, what is Q into 2a? It is P, which is the dipole moment. Right? Q into 2a is P, which is the dipole moment. So you can write it as P sine theta. Okay. So now, if you will observe, you can understand that this torque, the dipole moment and the electric field, they are mutually perpendicular to each other. Okay. So this is a cross product. You would have studied about dot product and cross product in your last year's class. So this is cross product. So you can write it in the form of cross product. Tau vector is equal to P vector cross E vector. Okay. This is the torque experienced when a dipole is placed in a uniform electric field. Okay. So now, what is the condition at which the torque experienced by this dipole will be maximum? You know that sine theta will be having maximum value when theta is equal to 90 degree. Sine 90 is 1, right? So sine 90, so that means the angle between P and E should be 90 degree. So when will you get the angle between P and E as 90 degree? When the dipole is placed perpendicular to the electric field. So plus Q minus Q. This should be your direction of electric field. So when this is the angle between the dipole and the dipole moment and the electric field is 90 degree, the torque will be maximum. Okay. And minimum value, sine 0 is equal to 0. We all know that. So when theta is equal to 0 degree, the torque will be 0. That is the minimum value. So the maximum value of torque is P. Minimum, this is the maximum value, and minimum value of torque will be 0. Okay. So yes, that is what, when the dipole is released, the torque will tend to align the dipole with the electric field. That is, it will make the angle between the dipole moment and the electric field as 0. When theta is equal to 0 degree, torque will be equal to 0 because sine 0 is 0. When theta is equal to 90 degree, the dipole moment will be perpendicular to the electric field, so that the torque will be maximum. The maximum value of torque attained is P. Okay. So now coming to the dipole in a non-uniform electric field. We have seen so far as uniform electric field, right? So that the two forces experienced by the two charges in the dipole were equal and opposite, so that they accounted to 0. Now consider the case, in case if the dipole is placed in a non-uniform electric field. What will happen? So the force experienced by the two charges will not be equal. There will be force in the plus Q charge and there will be force in the minus Q charge, right? So what happens? There will be a difference. There will be a value of net force in the dipole. Okay. Similarly, a net torque will also act in the dipole, because when there is a force and a distance, perpendicular distance, there will be obviously a torque. So the net torque will depend upon the location of the dipole in the non-uniform electric field. Okay, so here we have taken R as the position vector to represent the center of the dipole. Okay, so that here we can see based upon the position vector, we will come to know how the torque and the force will make movement in the dipole. Okay, so what will happen when dipole is placed parallel to the electric field? Okay, so we know that let us draw the direction of the electric field in this way. So dipole is parallel means dipole moment is parallel. That means we are taking the charge minus q plus q. So this distance is taken as 2a. And the direction of the dipole moment, you know, the direction of the dipole is from negative to positive. So this will be the direction of the dipole moment. Okay. So the force on minus q charge, F of minus q will be in this direction. Similarly, F of plus q will be in this direction. What will be the direction of the net force acting on this dipole? So the direction of the net force will be in the direction of the increasing electric field. Okay. So this is because of the fact that force will depend upon the orientation of the dipole with respect to the electric field. So direction of force net force we can say, because we will be calculating net force only. Okay, direction of net force will be in the direction of the increasing electric field. So the reason is force depends on the reason we will write. Reason force depends on the orientation of P dipole moment with respect to electric field. Okay. So the direction of the force and the direction of the dipole moment will be same. Now coming to, this is the pictorial representation taken from the textbook. So this is the direction of the electric field, dipole, force on minus q, force on plus q. But the direction of the net force is in the increasing direction of the increasing field. Okay, because the force depends on the orientation of P with regard to E. Now what will happen when you are placing the dipole anti-parallel to the electric field? So this is the direction of the dipole, right? We have already seen that the force will depend on the orientation of P with respect to E. So when P is in this direction, the force will also be in this direction. Okay. So the force will also be in this direction. Here you can see the charges are changed because the dipole is reversed. It is placed anti-parallel and the direction of net force will be opposite to the direction of the electric field. It will be in the direction of the dipole moment. These diagrammatic questions will be asked to be explained. Read the question, understand the question carefully and attend the answers. Everything will be from the textbook, but the questioning method alone, you have to have a clear understanding. Okay. So with this, we will move on to some questions to test your understanding. See the first question. Draw the orientations of a dipole in an electric field corresponding to torque tau is equal to 0. We have already discussed when theta is equal to 0, torque tau will be equal to 0. That is, the dipole should be in the direction of the electric field. Okay, or it can be either parallel or anti-parallel to the electric field. If it is parallel also, theta will be equal to 0, or anti-parallel also, torque will be equal to 0. Okay. And when will torque be maximum? Theta is equal to 90 degrees. So that when the dipole and the electric field will have an angle of 90 degree, then theta should be 90 degree. Okay. This case, torque should be half of maximum. Maximum is 1 P, right? So maximum value of torque is P. So half of P, when will we get? We need half of P. That is, what will be the angle at this case? Sine 30 degree is equal to 1 by 2. So when theta is equal to 30 degree, torque will be tau is equal to P sine theta, right? Sine 30. So it will be sine 30 is 1 by 2 P. So you get half value when theta is equal to 30 degree. So let us see the diagrammatic representations here. So this is for the case torque should be 0. First case. Second case you can see here. The dipole is and the electric field have an angle of 90 degree. Okay. Third case, theta is equal to 30 degree. This is how you are expected to answer this question. Now we will move on to another question. An electric dipole consists of two opposite charges of magnitude 1 by 3 into 10 power minus 7 coulomb separated by 2 centimeter. Dipole is placed in an external electric field is given. You are asked to calculate the torque. Okay. So, and one more thing, the keyword is what maximum torque. Maximum torque means theta, you are expected to take it as 90 degree. So, you know the value of Q, 1 by 3 into 10 power minus 7 coulomb and separated by 2 centimeter. So, 2A is equal to 2 centimeter. 2 centimeter means it is 2 into 10 to the power minus 2 meter or 0.02 meter. Anything you can use. Electric field is 3 into 10 to the power 7 Newton per coulomb. Now the torque tau is equal to P sine theta. You know the formula, right? P will be Q into 2A, right? So substitute that. Q is 1 by 3 into 10 to the power minus 7 into 2A is 0.02 or 2 into 10 power minus 2. Then you have the electric field 3 into 10 power 7. Theta should be 90 degree because maximum. That means sine 90 is 1. Okay. So now when you solve this, okay, 3 and 3 gets cancelled, right? And minus 7 and plus 7 will get cancelled. So the answer will be 0.02. What will be the SI unit of torque? So what is the SI unit of electric field? Newton per coulomb. Electric field it is Newton per coulomb. And dipole moment, Q is C, 2A is meter. So it will be coulomb meter, right? So now coulomb and coulomb minus will get cancelled. So you will get this as the SI unit of torque. So it will be Newton meter. Okay. This is how you are solving the sum. So at what condition torque acting on a dipole in an electric field becomes maximum? Theta is equal to 90 degree. So maximum value of tau is P. What is the maximum value of torque acting? Tau is equal to P. Now, next question. The torque acting on a dipole is tau is equal to P cross E. Name the pair of vectors which are perpendicular to each other. So now, as I told you earlier, these three are mutually perpendicular to each other. So the pair of vectors will be tau, tau and P, dipole moment, tau and E. They are the pair of vectors which are perpendicular to each other. Okay. I hope this concept is clear to you. If you have any doubts, you can raise in the comment section. We will be happy to help you. Thank you.